Good morning, stat students, and happy Wednesday. Today we're taking notes on cumulative relative frequency plots to box plots. And then for your practice, you'll be kind of going back and forth from one to another. So let's check this out. This is just kind of an example. It's not really any crazy notes, just showing you guys how to do this process. Botanists measure the height of 150 saplings. The data is represented in the cumulative frequency graph below. So it's important to realize that this particular example I'm showing is with a cumulative frequency graph. That's important because cumulative relative frequency obviously goes from 0 to 100%, and it's much easier to read those values. I wanted to show you what cumulative frequency looks like. So we looked at 150 saplings. We're going from 0 to the full frequency of 100, and we're going to try and build a box plot off of this, okay? Use the cumulative frequency graph to find the 5-number summary for the height of trees. Okay, so let's go ahead and write up what our 5-number summary is, just in case we forgot. So we're looking for our minimum, our Q1, our median, or our Q2, Q3, and our max. Okay, so for our minimum, you can look to your graph to see where that's at. I'm gonna zoom in. It's right here at 0.55. So my minimum height of my trees, 0.55. Okay, for my Q1, remember my Q1 is the boundary for 25%. So I want to find where 25% of the trees fall. If this was cumulative relative frequency, I could just read over to 25%, hit the graph and come down. However, this is cumulative just frequency. So I have to find out what value represents the boundary for 25% of saplings. So I'm going to do that by multiplying 150 by 0.25, and I'm going to get out 37.5. So that's the value I'm going to look to on my y-axis, or the frequency value that is representative of 25%. And one thing you need to make sure of is that these are just rough estimates, okay? There's no way for us to really, depending on the scale, get a perfect figure, but a rough estimate will give us an idea about the shape, center, spread of the distribution, okay? So let's check this out, 37.5. So we're gonna come, and I'm gonna say it's probably somewhere here. I'm gonna hit this graph, and I'm gonna come down, and this is my Q1 value. And I'm gonna estimate that to be around 58.58. 0.58. It's just an estimate. Q2 is 50%. So I'm looking for that mark that represents 50%. So 150 times 0.5 is 75. And I'm going to go read that value on the graph. 75 is an exact point on the graph. So I'm going to read 75 over to the function and draw a line straight down, as straight as you can. If I was in person, I'd probably use a straight edge. There's my Q2, or my median, which we're gonna estimate as, I don't know, 63.63. And my Q3 is 75% of the data, so 150 times 0.75 is gonna be 112.5. So I'm gonna go estimate that. I'm gonna say it's probably somewhere right here in the middle. Again, as straight as you can. It's kind of hard on an iPad, so I understand. There's Q3. It's kind of messy. I'm gonna estimate this to be about 0.67. And my maximum, where 100% of the trees are, is about right here, which is about 0.79. So we just use a cumulative relative frequency plot to estimate the 5-number summary. If these intervals had been more defined, then obviously the more accurate it will be. We're not going to beat ourselves up over accuracy. Even if we move just a little bit, this value is not going to change too much. So we're just going to know this is an estimate and do our best. Next one tells me to check for outliers. So I'm going to find my IQR. My interquartile range is equal to Q3, which is point. Oops. Sorry, I accidentally hit the home button, so I don't know what happened, but my Q3, which is 0.67 minus 0.58, and that is going to give me 0.09 as my interquartile range. And I'm going to multiply that by 1.5, and I'm going to get out 0.135. So I'm going to take my Q1 of 0.58 and I'm going to subtract off 0.135, and I'm going to take my Q3 of 0.67 and I'm going to add 0.135. And we're going to see what we get for this boundary here. I'm going to get 0.445 and 0.805. Okay, so what you should realize is that although we don't have any specific data points, I can realize that my minimum and my maximum fall within this boundary, so therefore there are no outliers. I can make that assumption. So we're going to go ahead and say there are no outliers. The min and the max fall within this boundary. So no outliers. If the minimum and the maximum either way fell outside of this boundary, we wouldn't know exactly what the outlier values are, but we would know there are outliers present, and that's worth mentioning, okay? Now we're going to draw a box plot or a skeletal box plot, and we're going to explain our choice. So will it be modified or skeletal? This is definitely going to be a skeletal box plot. And there's a couple reasons, okay? So since there are no outliers, a modified box plot is not needed. However, even if there were outliers, we would still use a skeletal box plot. And that's because we don't have specific data points. And usually when we go cumulative relative frequency to a box plot, we're going to use skeletal, okay? Because there are no specific data points. Okay, but it is important that outliers are mentioned. So every graph has why it's important. Our cumulative relative and also cumulative frequency plots gives us a lot of insight about percents, about values, about some predictions we can make about the graph. And a box plot gives us a kind of better idea about shape, center, and spread of the data, okay? This is more about kind of trending. This is about shape, center, and spread. So let's go ahead and make that box plot now. I recommend that you use the same scale on your box plot as you have on your cumulative relative or cumulative frequency plot. So I'm going to use the same scale down here. So I'm going to go 0.55, 0.6, 0.65, 0.7, 0.75, 0.8, and I think that's all I need. And of course, this is height of trees in meters. All right, and so let's get plot in here. My minimum is 0.55. My Q1 is 0.58. Q2 is 0.63. Q3 is 0.67. And max is 0.79. Again, estimate is not going to be perfect, especially the way that these boundaries are set up. So there's my box plot. And part D is asking me to describe the distribution. And remember, whenever we talk about describe, we're talking about those three things: shape, center, and spread. And they should all kind of flow into each other. So here's what I'm going to say about my box plot. All right, so the distribution is skewed right. Okay, so this indicates that the typical height of a tree or a sapling or whatever we're talking about, tree, for the middle 50% of trees is what I mean by typical. Are about 0.58 to 0.67 meters tall. And that gives us, you know, with a median height of 0.63 meters. Okay, so there seems to be few trees that are a little bit taller, causing that skew, between 0.67 and 0.79 meters, and this is approximately 25% of trees. Okay. Fewer trees are less than, what is that value? It's 0.58. Less than 0.58 meters tall to 0.55 meters. All right, there are no unusual values or outliers. And you can say something like, it's more common for a tree to be over its average height, its median height, than below, something like that, okay? So as long as you get this shape, center, and spread in there, you're good. So I need all three: shape, center, and spread. So this is what you're working on today. You're working on taking box plots to cumulative relative frequency plots. Also, you have one question on your practice about matching some histograms to box plots, and we'll go over it on class on Friday. Hope you have a wonderful Wednesday. Bye.